Hello, everyone, and thank you so much to be here with us this morning or afternoon, depending on which side of the ocean you are. My name is Erwan Deschamps, and I am a regional sales manager at Famic Technology Montreal, and will be your moderator for that webinar. So today we have an amazing panel to discuss about Dana catalogs and application using Automation Studio. So for that presentation, I will have the pleasure to be with Francesco Canestri, Fluid Power Virtual Validation Engineer from Dana, Vincent Rémiard, Corporate Account Manager for Famic Technology, and Luca Berto, Product Support from Famic Technology too. So as you may see, for those who don't know, go to webinar, there is a dial box where you can type all your questions. We will answer them at the end of the presentation during the Q&A period. So now, just let's see what we're gonna see today for the next 90 minutes. So first, some quick introduction of Famic Technology and Dana Incorporated by Vincent and Francesco. Then we are going to explore the Dana Brevini Motion System catalog in Automation Studio with Luca. Afterward, Francesco is going to present different Dana cases in mobile and industrial application. And finally, we will have a question and answer period and the conclusion. So the session will be recorded, and we will be sharing this webinar with all of you after it. So now let's start with Famic and Dana introduction. So Vincent, are you ready?
Yes, am I? We're good. So thank you everybody to have joined this webinar. So a couple of information regarding Famic Technologies, who developed automation software that we're going to explore today. The company was founded 35 years ago, mainly in this software development activity involvement. We have expanded over years. We have headquarters in Montreal, here in Canada. We have also a branch in Germany, and there's engineering support also from India. Couple of software developed over years. The main product remains Automation Studio, which we can find professional and educational edition. And we newly added also an add-on or a specific workshop dedicated to manifold design. So it's really to complete the package. And we are also working actively on other platform more related to Industry 4.0 and so on. So we have a suite dedicated for that called Endon Studio as well. So today we're going to focus on Automation Studio Professional edition. So a couple of interesting milestones. So once again, everything started a long time ago with pneusim and hydrosim, mainly for pneumatic training, hydraulic training. When we moved to Automation Studio around those time. But really, it's in 2003 pushed by important OEMs and mobile hydraulic that the modern, I would say, version of Automation Studio start to be developed. So we added everything required to simulate and to manage mobile hydraulic project and so on. In 2011, we continue developing manufacturer catalogs and relationship with manufacturers. But in 2011, it's really where we make Automation Studio at the corporate level. We make it able to be deployed in corporation, be used as a corporate tools. And really in the 7.0 that we released approximately a year ago, we added some key feature that to make our user benefit even more using Automation Studio. So the block manifold and also a failure mode and effect analyzers module, okay, an FMEA module. Okay, but since the beginning, we developed at Famic Automation Studio to really cover all the different technologies that you will find in your mobile and industrial system. So hydraulic, mechanical, electrotechnical or electrical, all the control also is there. We have open bridge to do co-simulation with the software and so on. And of course, we also have feature to document and make sure that you complete your project that you made out of Automation Studio. Okay. So also it's an important slide that shows the motivation of Automation Studio since the beginning is to be used in all project life cycle steps. So from the initial sales discussion between OEMs, manufacturers, system integrators, up to doing the complete system design and validation, be able to reuse that work for training, for commissioning of your machine. So really this is an important aspect, and this is the philosophy that motivates our development of Automation Studio over years. Okay? So that vision make us develop a variety of market. So since we deal with system, we are present in all of those markets. Okay? Distinctive fact, so Automation Studio remains a CAD software and a simulation software, but the way that we are developing things make it what we call the machine knowledge solution. Okay? So to just to end this introduction, I will let you explore some machine knowledge benefit that you will find using the software in terms of work process and so on. So reduce cost, being more efficient, building your machine, diagnostic them, improve the design, re-engineer some of your machine and so on. And of course, if we focus a bit more on the engineering, the system design in hydraulic, electrotechnical, you will also get a lot of benefit out of Automation Studio. So thank you for that first part.
Thank you, Vincent, for that presentation. So Francesco.
Yes, I'm ready, Erwan.
Okay.
Let me share my first screen. Okay. Hello to everyone. My name is Canestri Francesco, and I'm a virtual validation engineer employed in Dana since 2018. And it's a very pleasure for me to be here to present, first of all, our company. Let's move to our first slide to give you a brief overview about Dana. That is a global company founded in 1904 that is headquartered in Maumee, Ohio, in US, and that employ 38,000 people spread all around the world. Dana in 2020 sales $7.1 billion and covers a lot of vision, mission, and values. In fact, our mission is to powering innovation to move our world, and it has a mission that is based on our vision, that is driving stakeholder value by powering vehicle and machine around the world, shaping sustainable progress through invention and execution, and making the amazing happen wherever people live, work, and play. And all these points can be summarized in our company themes, that is people finding a better way, where people represent our four core values: value other, inspire innovation, grow responsibility, and win together. And now let's introduce you, Dana, with a brief corporate video.
There's an old saying, if you always do what you've always done, you'll always get what you've always got. Some might see that as a negative, but what if what you've always done is find a better way and end up with a better result? A better way to convey power, eliminating sprockets and chains by inventing the encased universal joint, unchaining the automotive industry. A better way to engineer integrated powertrains, a better way to move vehicles forward. What if doing what you've always done means strategically placing yourself closer to customers around the world, or always finding better ways to efficiently transfer energy to the wheels for not only light vehicles, but commercial vehicles, off-highway equipment, and for off-road enthusiasts? What if doing what you've always done means fueling a high-performance culture with the best and brightest people? What if you've navigated through over 115 years of vehicle evolution and are leveraging decades of vehicle electrification expertise to revolutionize power conveyance once again? If you're always finding a better way, you'll always be a step ahead, and you get to move the world. Dana, people finding a better way.
A very nice video. Let me show you my screen now again, and you can see it. Let's have a brief vision about Dana Incorporated business. Mainly, the business covered by Dana will be defined in three, and like the light vehicles, the heavy vehicles, and the off-highway. And to represent better these markets, Dana decided to divide itself in four main segments or business units: light vehicle drive system, off-highway drive and motion system, commercial vehicle drive and motion system, and power technologies. And each of them presents different kind of fields and technologies that could be summarized in the list you can find in the right part of the slide. So drive, motion, electrodynamic, thermal, sealing, and digital. And then we can say that a lot of Dana systems and product will be found in different applications, like the Ferrari SF90, or that is a mobile one, or the stationary one that could be represented to the hydraulic mechanism that you can find inside of the Panama Channels doors. If we would move to the off-highway segment, we can highlight that it is divided in two main sectors, the mobiles ones and the stationary ones. The stationary one is only represented by the industrial field, instead of the mobile one could be defined and divided in four main subcategories, like the agricultural one, construction and forestry, mining and material handling. And for this reason, the brands owned by Dana off-highway would move from the drivetrain system to the sealing one. But today we will focus on the Brevini Motion System valve, because this is the ones that deal with the fluid power components. To end my first part of the presentation, I will highlight what Dana as like innovations. So last year, Dana presented more than 10,000 patents, and this was possible due to this extended network of technical centers spread all around the world, and that employ more than 2,000 engineers. So for this reason, we were able to, for the 9 consecutive years, to participate as PACE Award as a finalist and to win 5 of them. And after that, I will give you the floor, Erwan, to the next part of the webinar.
Yes, thank you, Francesco, for that nice presentation. So now let's move on the Dana Brevini Motion System catalog. Luca, are you ready?
Yes. So thank you, Francesco, and exactly as you said, we developed the Dana Brevini Motion Systems catalog in Automation Studio. So based on our collaboration with Dana, we developed these families of products, and you will be able to access them via our website, so the Famic technology website, going under the Brevini family of catalogs. We have 3 of them. I will introduce you the content of those and show you how you could use them to create your schematics and simulate your systems. So the first one is the one called Dana Brevini Motion Systems valves, that contains mainly the industrial application valves. So we have a section dedicated to C-tops valves and blocks, where we can find directional control valves, pressure control, flow control, the modular section for the C-tops, the proportional C-tops valve as well. So just to give you an idea, let me show you the symbols while we go through those products. So we have the different actuator for the directional valve, for example, so electrical or lever actuator or hydraulic actuators and so on. For example, there we can see an hydraulic actuator as well. We have the components that are meant to control the flow, the modular elements that are the subplates that can be stacked with the directional valves, so always sit-up elements. And of course, we saw the on-offs that are the AD family of products, and we have the proportional valves, so the XD family of products for the sit-ups as well. In this catalog, there are also the cartridge and logic elements, so sleeping elements with their covers, and the screw-in elements or inline elements. We have so all the different families of products. There we have, let me just show you a couple of them. So you have all the portfolio from Dana Brevini valves. In this catalog, you also have access via this icon to filter the products that are compatible with our Automation Studio manifold module. So where you will be able to create a 3D manifold starting from the schematic that you draw in Automation Studio. And you see that as soon as I filter for those, right now I only have the screw-in elements available. But soon there will be also the sit-up compatible elements for the 3D module. So in the upcoming updates of this catalog, you will have access to those as well. Now, let me show you what's inside this Catalog Explorer. So we saw the tree structure with the different products. Then you can open this right section, and for each type of product, you can, for example, let's take in sit-up 5 valve. So you have the characteristics, so the operating conditions. You have a picture that is the same that you find over there in the corner, and you have some documents. The PDF where there is the specification of the product, so you can look for the specific product, see how it is configured, and what are the different characteristics, as well as you have a test bench. The test bench file is our way to provide you information on the model behavior. So it's a project file in Automation Studio where you can simulate the product and see how it performs, if it is respecting and how it is respecting the parameters, the performances declared by the manufacturer in the technical specification. So in this case, we see how is respecting the pressure drop curves. There is a legend and some instruction on how to operate the system to test the different configurations, so the different pressure drops and so on. And this is true for all the catalogs. So you have the list of the products, so this list, and the additional information in this right side panel. The next catalog that I will present you is the pump and motors catalog. Right now, we only have the motor side of the Brevini portfolio. The pumps will come with the future updates, so next year in 2022. But for the moment, you have access to all the orbital motors, so BG, BR, AR, and so on. So the different type of motors that are fixed displacement motors with the optional valves as well. For example, this is CTM motor is a motor that is integrated with a reduction gear set. Or you have access to the SH family and B5VR, so the new products from Dana that are variable displacement motors. So with the different type of controls. Now I'll close this and I'll go back on a blank page there. So I can show you how to use these products. So once you have identified the product that you want, you can click on this icon to configure the product. What that icon will open is a series of menus that are based on the specification, so on the PDF of that product series, and you can select the different parameters for your motor. So you have the same structure as you find in the PDF, and you can select which type of valves or which type of shaft and so on. So once I have configured my product, I can insert that on the schematic. And so my product will appear there. If I have a bill of material on my diagram, the bill of material will be automatically updated with the information that is built from the catalog. So in this case, I'm just showing the manufacturer and the part number, but you have all the information that we saw in the data part for the specific product. You can as well take a product from the catalog without configuring it, inserting it on the diagram, and then directly from the diagram, you see right now, I have that product with no part number because I haven't configured it. But directly from the diagram, I can double click on it, open its property, and we have this part number section that takes the same window that we saw from the catalog, so the same configuration, and you can configure it directly on the schematic. So in this case, I will add, for example, a brake to my motor, and let's keep the braking valve not empty and painted. Okay. So, and as I apply my selection, my symbol on the diagram will be updated with the new symbol with the valves that I've selected, the brake and so on, and my part number table in my BOM is also completed. I show you, well, I'll take one more minute just to show you, for example, another kind of document. So we saw the test bench for the performance. Sometimes we also have a test bench with some application example. In this case, we have a variable motor. I can simulate the system, and I can select the direction of operation of my motor. I can apply a proportional command to my control valve. So I'm sending with my joystick here, I'm sending a signal to this solenoid valve to control the displacement of my motor. And I can see the performance that I can measure at the output shaft, and I can also apply some torque. So see how it behaves based on the operating conditions. The third and last catalog we have, I increase this side so we can see the third one as well, is the Dana Brevini mobile valves. So mobile valves contains 3 families, the bankable valve, the HP valve, so hydraulic proportional valves, and the phase out DCV series. So this is not a series that is available anymore from Dana, but we have it for backward compatibility. So the bankable valve are structured by modules. So you have the different inlet module, working section, and then the outlet module. And as for the previous components, we see, for example, in this working section, I have here an empty space that with, as soon as I configure my product, will be filled with a directional valve. The HPV is structured in the same way. but there is, since the HPV configuration is different from Dana side, the configuration is to be done a little bit more manually. So you will be able to select a working section, and then you have here the different inserts for example, the eye relief valves, and you have a section for these pulls as well. But since Francesco has some application that integrates HPV, and he will be able to show you better than me how to configure and how to use this family of valves, I will give back the presentation to Francesco.
Thank you, Luca. Thank you again.
Yeah, thank you, Luca, for that presentation of the Dana Brevini Motion System catalog. As I explained at the beginning, if you have questions, you can write them in a dialog box, and we will answer them during the Q&A period. So yes, now as you mentioned, Luca, there is the HPV component, and Francesco has some nice application that he can show us now.
Thank you, Erwan. Let me share my screen to give you the possibility to better going inside the HPV world. HPV surely can be considered one of the most interesting Dana fluid power products. As you can see, the hydraulic proportional directional valve series is divided in three sizes: the 41, the 77, and 310. And each of them have the main aims to obtain optimized performances and the integration of the greatest number of functions, that some of which are listed in this slide. Moving to these ones, I want to highlight you how our catalog page can be presented, and is easy to understand how many components are necessary to assemblate an HPV, starting from spools and going to working sections and other parts. But the collaboration between Dana and Famic allow everyone to be able to open the Dana Brevini Motion System mobile valves catalog, and in a fast, user-friendly and smart way, be able to configure his own configuration for the HPV and to try and test it. Now let's move with some video pills to understand how easy and how user-friendly is configuring it and test it. In this video, I want to show you first of all, the Dana templates. Have a look on the automated bill of material that we can find with already embedded all parts number and the references note that you want to add for each components. For the same way, on the other part of the document, we can find for our template all the data necessarily to define the project and the document and the owner name of the schemes. Zooming out, we can see that this case is taken from the Famic application testbed shown before by Luca, and you can access to it simply surfing the folder and activating and selecting one of them. And in this case, you can be linked to the HP141 application. Now let's have a look to the configuration of the HPV. In this case, we have an inlet section, two working sections with two dedicated spool configuration, and an end section. And this structure, as Luca said before, is the same that we can find in the Automation Studio catalogs. In fact, you can select easy inlet working section and end sections. Now let's move to another video. These video pills enable us to understand how it's easy to configure a working section. For example, if we select in the working section folder the with pressure compensator 1, we can choose the last one, and clicking on the preview, we can see if the one that we need. After that, in the on the gear icon, we can select our preferred specs, and automatically we will obtain the specific part number that can be exported and in the document with the drag and drop, and then the right part number will appear in the bill of material. We can move it where we want inside our document, and in the same manner we can configure every types of spool, with the main difference that and we will see it when we click for example on the sides for flow control double acting, that every spool is already coded, so we need only to drag and drop it to obtain the right part number in our bill of material. So drag and dropping it and moving it in the right part of the working section, we can obtain our hydraulic scheme. Deleting the working section predefined and the spool that we imported, now we are able to try to run our simulation to understand how easy is control and monitor if the design we prepared is well or not. For example, we can move our joystick and see if for a predefined spool position, our schemes have the expected behavior. And in this way, we have also connected a pedal that allow us to change the resistive torque for the wheel. And in this reason, we can understand better if our hydraulic scheme is well designed to supply in the right way the motor. With this part, with this video, I ended the first example for one of the user case developed by Dana. But we will see now another one that is very different from the previous one, because now we will talk about a wind turbine crane that is a stationary application, and that show how Dana businesses are very different and extended. One of the most important features of this application is that it represents an integration of Dana components, so not only fluid power components, but also others like electric motors, winches, and gearbox that are already produced and developed by Dana. And this kind of application embrace also Dana mission to shape sustainable progress for a green world, with the engineering as the main actor to reach success. The last important point that I want to highlight is the safety function and control logics implementation, because as we are developing systems, more and more customers ask us to define the logic behind the integration of those systems in order to implement new and more efficient safety function. And Automation Studio give us the possibility to do this because with the Dana Brevini Motion System valve catalogs, we are able to use all our products and to share also it with the customer, involving directly them in the design and concept phase, and also sharing with them our configuration and our logics. So the relation with them is continually increasing, and it's still rising the level of our design process. Let's have also here a brief overview about the hydraulic scheme. In fact, it's possible to highlight the three main working functions for the crane, so the extension, the rotation, and the elevation, that directly could be activated with the extension, rotation, and elevation joysticks. Other two important elements of the schemes are surely the two brakes that are necessarily for safety function, and the electrical circuit that enable us to activate and deactivate the safety function logics behind the valve. Also, now let's move to the catalog page in order to show you how the Dana Brevini Motion System catalog is composed. So the first section is the seat-up valves and blocks, and the second one is the cartridge valves and the logic elements that also contain the subfolder cartridge valves and inline valves. And now let's move to the second video, where I want to highlight you the simulations with the possibility to try to first of all activate some safety function. The first one is to close the solenoid 2, close the solenoid 1, and then reopen the solenoid 2 in order to allow the accumulator to be filled for the safety function. First of all, now we are able to move the joystick to the elevation, and it's easy to understand that we can rotate in both direction our motor. So the elevation function is working, and this in the same manner we can do it. We can do this for the rotations one. Those two working functions are the one that are also paired with the two brakes for the safety function. This is not possible for the extension for dimensional and design concept. For the elevation, we can do the same, moving our joystick, but also we have linked with our actuator the extension resistive load. And if we will plot our extension parameter connected to the actuator, we can easily understand how our system responds to output variation to the resistive torques. In fact, if we move the load, we are able to understand if something is going wrong, or if there is something unexpected compared to our requirements. This plot could be moved back in time also to understand if for a specific change in the input, the system responds with specific behaviors. Also, we can say that this plot could be exported to be shared maybe with customer or others colleague for design change and data analysis. And with this plot, I ended also the second test case, but we can now move to the last one, that is the intelligent twin steering system. The intelligent Dana twin system is designed for a mobile vehicle with two steering axles, so with four-wheel steering. As you can read, Dana evolved the traditional type of hydraulic configuration, introducing the possibility to disconnect the rear axle from the front one. In this way, the rear axle, through the electronic control of its valve lock, allow to improve the steering system performance and introduce advanced steering function compared to the conventional steering system. These sentences are extrapolated from the dedicated specific publication where this Dana solution that is already patented is presented. In fact, while the traditional functions that are implemented on two steering axle mobile valves are or for two-wheel steerings or for four-wheel steerings. The ITSS systems add two more advanced functions that can be highlighted, like the follow the path and the kinematronic rotation center, that I will explain in the next slide. Now imagine to focus on the first scheme on the left part of the slide, so the typical hydraulic steering system layout, where you can simply highlight the front axle and the rear axle that in a usual steering system could be simply represented by a traditional spool valve. Okay, in this way is not possible to independently control the rear steering angle and the front steering angle. But with the concept introduced by Dana, with the use of a standard HPV configuration, with the addition of a dedicated logical control and a custom valve for the HPV, for the spool of the HPV, is possible to transform, let me say, a typical hydraulic steering system in an advanced one. Where we use the Automation Studio in this process, mainly for two reasons and in two parts. The first one, to fast design the spool that allow the transformation to a typical steering system to a four independent wheel steering, and secondly to define and select which kind of hydraulic system architecture is the best for this kind of solution. Again, the introduction of a dedicated logics and control system allow also the possibility to activate the advanced function. Briefly, what happens when you switch on the ITSS, the valves, the customized spool valves moved in on the second position, so the front axle and the rear axle become independent, and the logical control optimize the steering angle to in order to allow the activation of the new function. What are these new functions? As I said before, the first one is called follow the path, and simply it's allow the rear wheels to follow the path covered in a ground from the front wheels, reducing the fields covered to the wall vehicles. The second advanced functions, it's called the Kinematronic rotation center, and in this way the logical controls act in order to reduce the Ackermann's errors for its wheels, and it allows the reduction of the wheel slippage up to 80%, and also give the possibility to have a reduction of the fuel consumption and the tire consumption. Now let's move to see the schemes for this application, that is very simple, but also that gives you an idea about it works. First of all, the front axle hydraulic blocks is composed by bankable section. Instead, the rear blocks is composed by standard HPV configuration, but as we said before, we introduce a dedicated valve for the to allow the transformation from the ATSS off to on. We also integrate this small electrical circuit where activating or deactivating the switch is possible to move from a two-wheel steering vehicle to a four-wheel steering one. Now we will try to run our simulation in order to show what happens if we only use a two-wheel steering. Simply playing with our joystick is possible to move the actuator from one side to the other to simulate the steering of the front axle. In fact, on the right part of the screen, you can see the graph that shows the signal of the front steering axle. So the rear ones are blocked. Instead of the front one can move to right, to left. In this second video, we will activate the solenoid free. So first of all, let's play the simulation. Let's close the second switch of solenoid free. And what we can observe is the change of position of our spool in the third one. And if now we play to our with our joystick, what we can observe is the translation of our vehicle with four-wheel steering, maybe to overtake an obstacle or something like this. So we are translating using four-wheel steering. In fact, the output signal from the front axle and the rear axle are the same. In this video, instead, we will activate the solenoid 4 after I played the simulation. And in this case, we will have a four-wheel steering, but with the movement that the vehicle attend is the a rotation around a unique center of rotation. So in this case, the steering angle for each wheel is the same in terms of value, but in not in terms of sign. In fact, the graph is showing that the signal are equal in module, but opposite in sign. Moving to our last video, now we are able to show that if we will activate the ITSS systems, the customized valves will move from the first position to the second ones. What happened to our circuit with this change? Simply showing the mechanism for each axle. If we will play with the front axle, what we can understand is that it changes in terms of steering angle, and the rear axle for instead it seems freezed, but it's not freezed. It is independent from the frontal one. So the control logic in this way can act as better you want in order to optimize the rear angle to activate the dedicated function, maybe the follow the path or the kinematronic rotation ones, compared to following what the driver want. And after this slide, I conclude my presentation for these three Dana applications. So, Erwan, I will give you the floor for comments and the final closure. Thank you again.
Yes, thank you, Francesco, for that free application. It was really nice. So let's now move to the Q&A period. So I'm gonna show. So you should be able to show my screen. Okay, so let's move on some question. We have a question regarding the components that are not available. So it might happen that in some cases components are not available or you are not able to find them. So maybe for that, Vincent, how do people need to proceed if they are not able to find the component in the catalog?
Absolutely. Can you make me a presenter?
Sure.
Just we'll return back to our website. Okay. Well, so first, if you want to explore what is available in those catalogs, so on the manufacturer catalogs, product manufacturer catalog page on Famic Technologies website, you have access to all the catalogs, and specifically, if you extend one manufacturer, you have access to the available catalogs. So for each of those catalogs, sometimes there's a little delay, but it's updated quickly. You have access to see all the details. So the first thing before you request a specific component is to go there and explore what has been developed in terms of part numbers for each of the product that are included in those catalogs. If finally you are not sure, or you think that the components you want is not available, you can scroll down here and you can ask a specific component. So this is a free service that we offer at Famic, coming with the maintenance and annual maintenance and support plan that you get. You could add a request, or you could ask for a specific component here. Okay? So the easiest way is to fill that form. It's important to understand that we will do it, no problem. It's really a frontline service. So you ask a specific component that you required. We will try, if the information is all there, publicly available, we'll try to make the component in a reasonable time frame, so up to 48 hours support for frontline, if we can, if everything is there and we can make the component. So it's really handy if you need 1-2 components really in a specific project you work on, and so on. So I hope this answered the question, Erwan. So
yeah, perfect.
Go here,
So,
you go manufacturer, you explore, and if there's a specific component, you could ask it, and if it's publicly available, we will make it. If it's get some customization, we could find a similar one to give you, and we could support you for the customization after that.
okay, perfect. Thanks. I think now we know the process for that.
Yes.
But as soon as we have the catalog made or the component developed, maybe Luca, you can answer that question. How do you validate catalog model versus real world component behavior?
Oh, yes. Well, that's a good question. So we as Famic Technology, we are a software development company, so we do not have sorry, let me share my screen. Okay, so we do not have the facilities to perform tests on real components. So we do not have a direct lab to test the components, but we rely on our relationships with the manufacturers. So in this case, with Dana, to confirm and to provide us the most updated data for their products. And I'll give you an example. For example, in this case, I have a PDF with, I'm sure there are, yes. So with some performance that are stated in the PDF. So the development process with Dana, we went through the products. They confirm us how to read these graphs and if they were indeed up to date. And we implemented the resulting performance in the components. So let me go take where is it? For example, I took this one, I'll just drop it here on the side. So, and we did implement in the valve the performance curves. So we have the pressure drop according to the PDF. But sometimes, and the HPV is a perfect example. So for the HPV spools, that information is something that is not publicly available. So you do not have in this PDF, you do not have the flow and the openings of the different spool positions for the different paths. So that's the advantage of having the agreement with Dana. We received the confidential data from Dana, and we implemented those curves in our component. So you will have access to that information in the manufacturer catalog, things that you cannot do via the PDF because you do not have that information, that kind of information published. And that's true for some HPV, from some, for example, if I remember correctly, we had the same case with some performance efficiency curves for the motors and so on. So we do this during the development, and right now that the catalogs are available and Dana is using them, if they find something while they are using it in the application that doesn't perform as it should, of course, they will give us the feedback and we will work together to implement the proper correction to the model to have a more reliable model in the end. So it's an ongoing process that is really a collaboration between the software side, so Famic technology, and the manufacturer, so Dana.
Okay, perfect. Thank you for this answer, Luca. I think this is a question that happens a lot. If you have other question, don't hesitate to put it in the dialog box. Otherwise, now I will have some question for Francesco. So Francesco, you show us some cases, some application. Is there other application where Dana usually use Automation Studio, and why do you choose it?
Yes, obviously, because our application engineer try to use as better as they can Automation Studio, because as I showed before, is a way to communicate fast and easy with customer, and also to try to fast define concept, and choose the best one for the solution. But we have surely other hydraulic application, so we use it for define maybe blocks for steerings, as I showed before, hydrostatic transmission, cooling systems also that involves maybe oils. So we used it in many applications, and we use it in a very high range of with very a high number of customers, let me say, So also internally, we try to use it also for defining the hydraulic scheme of our test benches, because for the test bench that for a dedicated test bench, we can develop different kind of hydraulic circuits, so define different kind of experimental tests. And why we choose the steering system, for example, as an example to show today, because for us, it's the first time we implement and use Automation Studio after the definition of the Dana catalog inside it. So it was very fast defining the HPV configuration that is already present. And in few time we are able to explore different solutions and say, okay, maybe this one that we choose fit better their requirement, and we can move to the core part of the application, and that involve also the paper, the publication, that is the control. So we save a lot of time in defining our hydraulic scheme, and then we can spend this time, our value, our knowledge on the control part, that is the ones that could add more value to the Dana integration solutions.
Okay, thank you, Francesco. So I really understand that it's important for us. I mean, with using automation internally, it makes you like takes less time for the design aspect and so on, and also improving the communication with your client and so on. So for application, it's quite interesting. Now I want to move on one of the projects you show us, the wind turbine crane model.
Yep.
In that model, are safety functions considered?
Yes, surely they were considered because we directly, as I said, worked with the customer in order to define it, because they are requirement also written in regulation. So we need to respect the European regulation, and safety function are the base of these regulations. So surely, if you make me presenter, maybe I can try to share my screen and have a look better in this type of application. Okay, I suppose you can see my screen now. As I said before, the first thing that we have to do when we start the crane is to load the pressure inside the actuator, because if the current is not available, so the electricity is not available for our system, we must be sure that all the movements, so all the working function, as the rotation and the elevation, could be avoided, closing the valves and being able to remove the load from our crane. So every kind, in this crane we have two different level of safety function. The first one deals with the presence of the electricity in the system. So we must be able to actuating, for example, this valve to close the circuit, so to allow the flow to pass in this valve, in this relief valve maybe, and not in the motor, so stopping the elevation working function. And the other one, that is the ones that act using the pressure saved in the accumulator, is when we not have electricity available, so opening this relief valve and let the flow go inside of it. So in this way, we are able every time to make our application safer, and to better integrate the usage of safety function in the design phase, involving the customer and working directly to him. Because, for example, for this application, we were able to define this system in less time, because the customer also have automation studio, so we have an exchange of data, and we were able to daily maybe to save it, to send it, sorry, for example, the scheme updated with the dedicated logical control behind.
Okay. Quite interesting that. Now that you show that schematic, after you show another application, which was the ITSS. That is very amazing, and I would like to know that what are the advanced functions introduced by that ITSS?
As I told you in the slide, the two functions that are also better explained and deeply explained in the publication are the kinematronic rotation center and the other one, the follow the path. Sorry, I don't remember, because many names and acronyms in my mind now. The first one, simply, as I said before, introduced, so the kinematronic rotation center introduced an algorithm that correct the Ackermann errors. And the Ackermann errors is related to the different steering angle that you can find basically in a tool steering. Imagine that you have more axles, so you have different Ackermann errors. So for 4 wheels, you have four angles. In this way, with the logical control behind the ITSS for the kinematronic rotation center, you are able to optimize this angle because the front axle and the rear axle are independent. And in this way, you can choose, the software choose which is the best angle for each wheels, and then implementing the function, the vehicle hydraulically correct the wheels and save maybe the fuel and the tire consumption. On the other hand, the function introduced is the follow the path. In this way, with the follow the path, the algorithm correct the steering angle of each wheel in order to allow the rear axle to follow the front one. So if you are in a field and you are driving a tractor, you are able to save, for example, more grass, because the rear axle is following the path that the frontal one have already covered. So we are also working on other functions that could be implemented with these schemes, and simply working on the logics. And again, as I said, Automation Studio give us the possibility to focus maybe to the logics and to the function, increasing the value that Dana can provide to customer, because it was very simply using our catalog, configure the hydraulic part, simulate it, and say, okay, every component hydraulically works, hydraulically is safe, so we can concentrate our energy to adding value to research and to offer the best solution for our customer in terms of functions and safety function also in this way.
Okay. Now that you are talking with, because you show us like these components, the HPV and so on, but all these components are in Automation Studio Catalog. We have a question regarding, can you supply customized valve model in an Automation Studio format? Francesco.
Yes, I think yes. We daily, our engineering department, to try to test as best as he can the solution is developing, daily try to use Automation Studio to design maybe some configuration and try to define which solution is the best maybe for an application or for a valve he must design. Obviously, we have a catalogs, and if we can start from a pre-configured part, is better, because we save time. We know that is already, that is, let me say, freezed and verified, so we can simply, as I showed before, drag and drop, and maybe in an example like this, we are able to design and define an hydraulic scheme with 10 elements, and maybe only one is customized. So we can focus energy on this component that is the customized and the custom one, and spend less energy to something that we have already designed and verified a few time ago.
Okay, perfect. So it's good to know for everyone listening that you are able to provide that. Thank you, Francesco. I have a question, another question regarding the exports. I mean, what kind of export do we have? Maybe Vincent, can you answer that questions?
Yes, absolutely. We did receive a question regarding the export. weren't sure what the exact export question was about. So let it be general. The schematic can be exported. I don't think I have my automation to open. The schematic can be exported in common format, PDF, SVG for web-based application. TIFF format is still also supported. DXF if you want to share a schematic with someone without Automation Studio and so on. So this is one export aspect. We have also the information from the BOM, from the BOM, that could also be exported. This one can be exported in Excel, SVS format, and so on. And if you are looking, yes.
Sorry to interrupt you. Could you share the screen and show where these options are?
No, I don't. Do you have your automations open?
Yes.
Maybe we can
Okay.
take over.
I share and follow your lead.
Absolutely. And you can take over, or I can.
No. You keep on going. I'll follow your.
So the export of the file is done with here we go, Automation Studio export, and you will see the various export, DXF, PDF, SVG, TIFF, and so on. If you are interested, we have another format. More and more of our users are interested to do that. It's the XML format. This XML format will give you all the net list of the connection between components. If you want to link with APIs, with your corporate tools and so on, this could be really handy. To do like connection verification, or there's a variety of application that could be done from this XML export. Regarding the bill of materials, so the bill of material and the reports build can be exported in a variety of formats. So you go and edit and you get this export. So Excel, PDF if you want a static bill of material, and so on. And this is where you get the CSV and Excel export. So one of the question was related to that. And regarding the simulation results, if you are interested also to export them, so as you run a simulation, you get all the information collected and so on, and you will be able then to export it in the text format that you could reopen with any by any spreadsheet or any of those software. Okay? So this was about all the exports, depending if you are interested to get information regarding the schematic, the bill of material, or the simulation results.
Okay. Thank you, Vincent, for that information, how to export, different way to export data. I mean, maybe there is a link with that question, because there is another question about is local distributor and approved dealers can have access to design and simulation. For that, I might be able to answer. There is different way. So we show how to export. You can have your own Automation Studio license when you have access to the software, when you can make the design and simulation. But we have also others kind of version. There is one version which is quite interesting. It's the version is called the runtime version. This runtime version allow you to, from a project, for example, that project, the pressure drop that that is showing Luca, you can have access to use this simulation runtime, which means that you are able to run the simulation. You will be able, so you will be in the simulation mode basically. So you can't modify anything of it, but you can run it. So it might be interesting in different ways to use that license, just to showcase to clients an application. We know that a lot of people are using it also as training material. There is development of this new machine made by a client, and then you want to share it with some of your with the dealers and so on, with the final clients. Then you will be able to use that. There is also another version which is called the viewer, the Automation Studio viewer. This version is kind of the could say as a opposite, which means that this version allow you to, or it's a version close to the PDF. It's a version that you can open PRX file so Automation Studio files that have been developed, but you cannot simulate it and you cannot modify anything, but you will have access to features as layers. We got layers, we got a translation manager and so on. So this version could be used very easily for different, for documentation purpose, or to share with a client who doesn't have who doesn't want more than only the PDF. So you can see that Luca just showing that here on the website. You can develop that Automation Studio viewer. By the way, it's a free of charge. It's a viewer, so it's free of charge license that you can have. Another question there was about there is a question regarding validation about some components. So maybe Luca and Francesco, you can answer that. There is a way that maybe default parameters or length of internal pipe, volume, and chamber, all those parameters are set in a component. I think this was the question that was asked. Maybe Luca, you can start.
Yes. Well, I see who is asking that. I think it's someone internal from Dana, so for sure we can adjust those values. By default, when we develop a model, we keep I don't know. Let's go. For example, there I already have a motor, so we keep standard parameters, standard dimensions for the lines. So there, if I select my line and see the dimension and characteristics, so we define the lines, but we do not configure these dimensions. So for sure, if it is something that is relevant for your simulation, we can adjust them. But there is also an option depending on what is your need. If you do not, sorry, if what you are looking for is to avoid having extra pressure drops, for example, there is an option in the simulation options, which are there, to set all the lines on a schematic to be perfect. So at that point, you will not have pressure drops across any line. So if I select that, and I close this, let me close that as well. I can say, okay, the lines inside the motor, I will disregard those pressure drops and those volumes, and I will only simulate everything, for example, that is outside. So I know this one is a long pipe, so I can select that to be perfect line false. Right now is inherited from the template, so from the simulation options. I can set that to be false. So I will simulate a pressure drop over there. And as soon as I run the simulation, you will see that I lost the animation on all the lines because those are perfect. So there is no calculation of flow direction or pressure drops, except from that line where I set that to be not perfect. But for sure, we can work on those line dimension if it is required for your simulation.
Okay.
Especially since you are someone from Dana.
Okay. Thank you, Luca, for that clarification.
Just
we got
to add, sorry, a little
go ahead.
to the Luca ones. Also for others people that are not my Dana colleagues, we can surely maybe together and with the proper, let me say, inlet way in Dana, we can surely have a look on this in order to provide the best support also to other to our customers.
Okay, thanks for that clarification. Francesco, as you are there, I have a question regarding the rotation, regarding the crane.
Yes.
Question is there a specific reason explaining why the rotation function on the crane application don't have an hydraulic safety valve in addition to the electrical one, as it is for the elevation function?
Yes, I agree with you. Yes, it's simply linked to the wind because our application engineer with this calculation said that as the wind has no important no important load applied on the elevation on the elevation beam and the elevation actuator, sorry, it's not important to introduce a safety function for this crane on the elevation working function. Because the load is mainly moved with the others two working function. So for those two is very important, follow the regulation and introduce a double level of safety functions.
Okay, thank you. I think it answered
You're welcome.
the question. Do you have, is anyone has other question? For the moment, it doesn't seem. So, as I mentioned at the beginning, this webinar has been recorded, and we will send you a link to review it in the next few days. I hope you enjoyed today's presentation. And let me thank all of you for your participation today and also to our speakers. If you have other question or do you want more information about Dana components, you can contact them on their webpage, dana.com. For Automation Studio, you can contact us on famictech.com. Dana and Famic could be followed on social medias, LinkedIn, Facebook, Twitter, and YouTube for news. So thank you all again for your time today, and hopefully see you soon in person soon. So thank you very much.